Hello all and welcome to my channel devopsmela and welcome to my series AWS DevOps. As promised, here we go. This is a complete AWS DevOps series. So let's see what exactly we're gonna do in this complete series. So basically we'll be talking about the complete DevOps technology stack in AWS. For code, starting with your source code management, we'll be using Code Commit for the same. For the build and test, we'll be using AWS Code Build. And for infrastructure, the same application which we have built earlier will be deployed on Elastic Beanstalk. And later, we'll automate the entire process, the build and the release process using Code Pipeline. So if you want to know about the similar stack, so I already have a Azure DevOps series in which I have covered Azure repos in details, I have covered Azure build in details, have deployed application on Azure Web App, and I have covered Azure release in details. So if you guys are interested in a similar stack, please check out my description or check out at the top. You'll find the link to my Azure DevOps end-to-end series. Okay, that is all about Azure. Let's focus on AWS. Okay, so let's see. So basically we'll focus on these 4 services of AWS, more precisely on AWS Code Commit. So as we know, AWS Code Commit is nothing but it's a secure, highly scalable, it's a private Git repository wherein you can host your private Git repository. On the other hand, AWS Code Build is fully managed continuous integration service that helps us to compile the source code, run tests, and produce software packages. So in short, at the end, we'll have an artifact output file which we can deploy. And AWS Code Pipeline. AWS Code Pipeline is a fully managed continuous delivery service that helps us to automate the build and the release process. And using AWS Code Pipeline, we can automatically trigger a build and we can automatically deploy. Okay. Elastic Beanstalk, will be using Elastic Beanstalk to deploy application. So in this complete series, I'll be taking an example of live application wherein we'll be deploying that live application on Elastic Beanstalk using the above services. So Elastic Beanstalk is an easy to use service for deploying and scaling web application and services. So that's it from the introduction. Let's move into the second part wherein we'll start with AWS Code Commit. Thank you. Hello all and welcome to my channel devopsmela. In this video tutorial, we'll talk about AWS Code Commit. Okay. So before we proceed, let's understand the agenda for today. We'll understand what exactly is AWS Code Commit. We'll create a repository using AWS Code Commit. We'll clone that repository and set up locally. We'll understand different types of how do we create pull, push, merge, and how do we tag a commit in AWS Code Commit. Okay, we'll understand different types of merge options what we have, like fast forward merge, squash merge, 3-ways merge. What are these? We'll understand that. We'll have an overview and we'll try and understand that. We'll create approval templates. So if you want to merge a change from your develop branch to a main branch, so and in between, if you want to have any approval process, a peer approval process, then we'll see how exactly that is done. And we'll have a custom policy creation. I'll show you how exactly do we create a custom policy if you want to block someone to push directly into a master branch or a main branch or any other branch. Okay, so these are the set of agenda which we would be following in this complete tutorial. Okay, so let's start. Let's understand what exactly AWS Code Commit is. Okay, so AWS Code Commit is nothing but it's a secure, highly scalable managed source control service. Okay, this will help you to host private Git repository. One more important thing, guys, I will not cover Git basic in this particular tutorial. We'll focus more on AWS Code Commit. And if you guys want any help regarding Git basic, I already have a video tutorial. You can find the link on the top or you can find the link in the description box. Please go and check that you'll get a clear understanding how exactly Git works, what are the phases and everything. Okay, please go and do check. Okay, so again, AWS Code Commit will help you to host a private Git repository. You can host private Git repository. There are many benefits of using AWS Code Commit. Okay, such as one more thing, in the backend, AWS Code Commit uses Git itself. Okay, it's fully managed. So yeah, it's integrated with AWS Cloud, so it is fully managed by AWS. AWS takes care of everything. Okay, it is secure. AWS makes sure the codes are secured on rest as well as in transit. So it's encrypted. The codes and everything is encrypted. Again, it is done by AWS itself. Highly available. You can just start pushing your code depending upon how many space and everything. So that is taken care by AWS itself in the backend. Okay. Collaboration on code. Easily you can collaborate your code with different set of developers. You can work on your code and you can share the code with the developers, and easily we can collaborate using AWS Code Commit. Faster development lifecycle. This code commit, AWS Code Commit, can be easily integrated with code pipelines and other AWS services. So your development lifecycle becomes very faster. You can use your existing tools. Okay, all your whatever services or tools you're using, you can integrate that with AWS Code Commit. So these are few benefits of AWS Code Commit. Okay, that's it about AWS Code Commit. Let's go and see how exactly we can create a repository on AWS Code Commit. So guys, I'm already logged in on my AWS console. So this is a prerequisite. You need to have a AWS free tier account. If you guys don't have, please go ahead and create a AWS free tier account. Okay. So when you log in, this is the first. I can go just look for code commit over here. Okay. So just click on code commit. This is the place where it takes me. Repository, source, getting started. We have a getting started page over here. This will again, if I click on create repository, it will take me back to this screen. Approval and rule templates. These are the sections on which we would be working. Okay, so let's click on create repository and create a demo. Demo repo. Okay, so let's create a demo repo. That's it. If you want to put anything in description, you can put it over here. If you want to tag it, okay, tagging is essential for billing and everything. So if you want to tag it, you can just tag. You can just give a name. You can just give a name, something like repo -dev. This is for development, anything as such. Okay. Enable Amazon Code Guru review for Java and Python. So if you have a Java and a Python project, you can enable it. It is nothing but it will give you a recommendation to improve the code quality. As if now this is not needed, so I'll just ignore it. I'll click on create. Okay, so here we go. The repository is created. As if now we have not initialized, or we have not added anything into it. Okay, so the repository is created. In order to clone, we can just select the option clone HTTPS or SSH. Okay, HTTPS, in order to clone locally using HTTPS, you need to first create credentials. Okay, I'm logged in with the ID devopsmela. So I need to create a code commit credentials for cloning this locally. The steps are given over here. The prerequisites are given over here. You must use Git client that support client version 1.7.9. I already have a Git client. If you're following me for the very first time, you can go and install Git for Windows, and you can just download the package from here, and it's just a exe. You can just do next, and Git will get installed on your local machine. And once it is installed, when you look for Git, you'll get something like Git Bash, Git GUI, and Git CMD. Guys, all this thing I've already covered. Please look into my Git tutorial wherein everything is covered. Okay. So yeah, I do have this. I'll go and generate credential. In order to generate credential, you have to go in IAM. Look for Identity Access Management. Okay, I'll just click and open a new tab. Go. I'll go in users. This is the ID which I'm using, devopsmela. Just go inside it. Okay, if you come down to security credentials, if you come down, if you see this HTTPS get credentials for AWS Code Commit, I already have one. Okay, if you see I already have one, I'll just remove it and I'll recreate for you guys. I'm just deleting it, coming back and generate credential. Do you see we have an option to generate credentials? I'll click on it. I just download the credentials. There we go. If I just quickly open this Excel, you'll see the credentials right over here. Okay, so there we go. This is the username and this is the password. Okay, this is the username and this is the password. We have the credentials now. Now let's go back to code commit. Okay, this is one way. The other way is SSH. So I'll not be covering SSH, but the steps are given over here. Again, in this SSH, you have to register your SSH public key. Okay, firstly, you have to generate the public and private key pair, and you can just follow the steps. And do let me know if you need a video tutorial on SSH. I'll surely create a video on SSH too. Okay, the steps are given over here. If you have any difficulty, do let me know. Thank you. Okay, let's do a clone. Let's clone this HTTPS. I'll just right click. I'll open my git bash over here. Let me make a big. Okay, that's visible. Let me do a git clone. Git clone. Oh, what did I copy? Let me copy it again. Do we have the link? Yeah. Shift insert. Yeah. Okay. Firstly, when you're cloning it for the very first time, it will prompt you for a user ID and password. So the credential which we just created, we need to enter that. Okay. Here we go. We have the user name over here, that is devopsmela at my account ID. And the second one is the password. Don't worry, this password would be deleted once I complete this tutorial. So even if you try and copy this, it will not work. Okay, warning, you appear to have a clone and empty repository. So that's totally fine. I know my repository is empty. So this is the repository which we have cloned. We are into a master branch right now. Okay. If I just do ls, there's nothing inside it. Okay. Let's create quickly something or echo. Let's create hello world. Just give a name hello.txt. Just do a git add and just do a commit. Hello world. Okay. If we do a git log, we can see our log. We can see our latest commit, that's hello world. Let's do a push and let's push it to my remote repository. So running the git push command, let's wait. Okay, so another push was successful. Let's come back over here and just refresh this repository page. Let's go inside it. Okay, I can see my file over here. Okay, that's hello world. Okay, one thing. And as if now we just have one branch, that is master, and we don't have any tags. We already saw this clone URL option when you want to clone, and if you want to add, you can add files directly from here. So I will not recommend doing this. I will recommend always using the local repository or IDE for pushing changes on your remote repository. Okay, we can create a pull request over here. As of now, we don't have any branch to create a pull request, so let's keep this option aside for now. There's an option called pull request. We'll see this. We'll come back to this section again. Now in this commit section, you can see your latest commits, and the commit is something pushed by Rohit KS. From where exactly we are getting this Rohit KS? Okay. Now this is, if you go and check the configuration, that is git config -l, check the configuration. This is the user email ID and the username mentioned over here. If you want to change the configuration, you can go ahead and do it. Go to config -, we can do a global, and you can give a name, name. You can change it to devopsmela. Okay, I can change the email ID too, but there's no need. Can simply go and check the username got changed over here, so we are good to go. Okay, now so that is the reason. So now when I start pushing again the new commits, you will see the author name as devopsmela. Okay, you can have a visualizer over here. You can it's kind of a graph wherein it will show the graph. It's a linear graph or non-linear graph, and you can see that thing over here. Compare commit, you can compare two commits, the destination commit with the branch. We don't have a branch to compare right now. We can compare the master branch commit with the develop branch commit or the release branch commit. We'll come back to this section again. Let's go ahead and create one more branch first. Okay, we can create a branch over here. We can go in branches. We can create a branch over here. I can just create a develop branch right over here, or I can create a branch from locally also. Okay, let's create a branch. So I'm creating a branch based out of master branch. Okay, so we have two branches now. I have a master branch which is by default, and I have a develop branch. Let's come back over here. Let's do a git pull and let's see if we are getting something. Okay, now if you see this on my origin, I have a develop branch. Okay, so we have we just created a new branch. Okay, so we can see a develop branch was created on the origin. Now, okay, when we run a git branch -a, so we're getting the list of branches what we have in my remote and as well as locally. So if you see on my remote, I have a develop branch as well as a master, but in locally I have only master branch. So let's do a git checkout. Git checkout will create the master branch, the develop branch locally for us. Okay, so the command is git checkout -b develop, and we need to merge this with my remote branch. Okay, so I need to give the origin, like what exactly the origin is of a develop branch. So I'll just specify the origin. The reason I'm doing it because this develop branch, this is something we have already created over here. Okay, so even my local and my remote repository should know that we have the develop branch locally as well as in my remote repository. It's invalid path. Give me one quick minute. Let me remove this. And okay, now if you see this branch set up to track remote branches. So now even my local develop branch, which we just created with this command git checkout, it will start tracking changes into my remote branch. Okay, so as if I'm a develop, I think that there's nothing we have committed. So if I just do a git pull, so basically we should get a message everything is up to date. Let's see, already up to date. Okay, there's nothing. Now let's quickly go ahead and create something like welcome to devopsmela. If you guys have not subscribed, please subscribe to my channel. Thank you. devop.txt. I'll quickly do a git add and just do a git commit. Post that, we'll see how exactly the pull request is created. Okay, devops dot okay mela. Now I'll just do a push. Now this changes which we are pushing, this is only it will only reflect in my develop branch, not in my master. Okay, that is the only thing that is the reason I was doing that. Okay, So if I just go in codes, okay, this is master. We are in master right now, and I can just see the file hello.txt. Now if I just go in develop, okay, I have that hello.txt as well as devops.txt file. Okay, now we need to create a pull request. Now whatever changes we have it over here, we need to push that change into the master branch. Okay, now we can create a pull request directly from here, or we can just go in pull request and create a pull request from here, whatever way you want. Okay, AWS gives a very good console of comparing two commits. Okay, so destination is my master where we want to merge the code, and develop is the source. It will do a comparison if there's any merge conflict or anything as such, and it will give you a window if there's a conflict. Okay, so as of now there's no conflict. If you come down, we can see the file. This is the file welcome to devopsmela, which is what we are adding. If you go in commits, you can see the commits. This is only commits, and the author is devopsmela as we change the username. Okay, now we can simply go ahead and do a commit, merging change with master. Okay, something like this. I'm just giving a title and giving a description. I'll create a pull request. Successfully created a pull request. As if now we don't have any approval templates or anything as such added till. So it's open, no approval rules, no merge conflict. We're getting everything at the top. The destination is master, the source is develop, the one who has created, that is devopsmela. Okay. Details, merging change with master, that's it. Activity, we'll get the activity history. Pull request just created. Changes, what changes are we pushing? Welcome to devopsmela, devops.txt. If you come to commits, this is the commit. Approvals, if there is any approval added, any template added, you'll see it over here. We don't have anything right now, we'll do it in future. Okay, let's just go and merge. Okay, if I come to this screen, it will give you three different merge strategy. Okay, so that is what the strategy we were talking about. What is fast forward merge, what is squash, what is three ways merge. Okay, the fast forward merge, in short, it's a merge. What you do, let me do a quick switch to master first. Now when I do a git merge, okay, and develop this way, so what it will do, it will get me the commits in the develop, and it will directly merge on the top of the master commits. Okay, what exactly that is, if you see this hello world, okay, on top of it my header with this head pointer will move on the top. They, it will not create any new commit, any merge commit. It will simply get this commit which is at the top over here, and it will put the pointer on top of master. How exactly it looks, we'll see it now. Okay, that is what fast forward git merge commit is all about. Git squash and merge. Okay, squash merge is very yeah, like you have to use it very wisely. Squash merge, what exactly it will do, it will squash all your previous merges. Like if for making changes, if you have done multiple commits, okay, so squash merge will squash all those commits, and it will create a new merge commit for you. Okay, so in short, if I just do a git squash over here, this particular thing will get squashed. You cannot see this commit in the master. On the place, you'll see a new, altogether a new commit created. Okay, that is a merge commit. So squash will squash your history, and that is the reason I said use it very wisely, because your history is completely gone. You cannot backtrack. So use it very wisely, and make sure you have a better understanding of branching and merging strategy, where to use squash, where not to use squash. I have covered this branching and merging strategy into my Git and into my Azure DevOps end-to-end tutorial. Please do check. You will find the links in my description, or you can check my playlist. Okay. So that is what squash merge will do. On the other end, what is three-way merge? Okay, three-way merge will create a merge commit, it will create additional merge commit, as well as it will procure all your history. Okay, so what will happen? Yeah, when you do a three-way merge, you can have this commit in your master, you will see this commit, as well as there would be a new merge commit created. Okay, so you'll have the history as well as a new commit created. That is what three-way merge is all about. Okay, so basically I'll do the simple one, the fast forward merge, and we'll see how exactly it looks. And later, when we're creating a multiple other pull requests, I'll show you squash and three-way merge as well. Okay, now, and if you see, just look at this option very wisely. Delete source branch, develop after merging. So if you want to delete your branch, so develop is not a temporary branch, so definitely not. So we can put up restriction that no one can delete it. Okay. We'll understand that later. For now, just uncheck it. I don't want to delete. Just create a merge pull request. So I'm merging my change. Now if I just go back to commits now, this is done. Okay. Now if you see, this was a commit which we did in the develop branch. It's this exact same. There's no new commit got created. It's the exact same. Okay. So if I just go and develop, this is what exact same. Okay. Now this is how you create a pull request. We'll again create a pull request. We'll see the squash and other things also. Okay. For now, for your understanding, this is how the git fast forward commit happens. Okay. Coming back to tags. Okay. Git tags. You cannot create a tag over here directly. If you want to tag something, you can tag it locally and push the tag into the remote repository. How exactly is done? Let me switch to git master. I'll do a git pull. So git pull will get me the changes which we just pushed using a pull request. Now if I just get the log, see where's my pointer? Head master, origin master, and origin develop. From where you're getting this chain, devopsmela. Okay, now imagine I want to tag. Imagine this commit which we did. This was a version 1.0. Okay, I want to tag this commit as version 1.0. Okay, there's no option right now in AWS to tag it, but you can tag it directly from here. So I just need the first 6 digit, and in order to tag, you can just do a git tag. You can just give a version 1.0, and you can just give the commit ID. Okay, that's it. The first 6 digit is more than enough. If you want to copy the entire thing, even that is okay. I'll just do a tag. Okay, now once you do a tag, still the tag is not pushed from your local to the remote, so you need to push it. So that git push hyphen hyphen tags. Okay, remember to use this flag hyphen hyphen tags. If you don't use it, even though if you just push it, nothing will happen. The tags will not reflect. So remember, so we have a tag pushed, and if you want to check that tag locally, you can just simply do a git tag hyphen l. You can see how many tags you have. Okay, coming back over here now, just refresh this. Do you see we have this tag now? Okay, now we'll create a approval rule template next, and then again we'll create a pull request, and this time we'll do a squash merge. Okay, let's do it now. Approval rule template. Okay, what exactly it is? So when you want to push your changes from your develop branch to your main branch or a master branch, that's a very critical. Master branch is something where your production copy of your code is kept. So you cannot allow anyone directly pushing changes into your master branch without a approval, a prior approval. Okay, so so that is the reason I'll create an approval template. And if you want to push anything into your master, that needs to be approved by the peer or anyone, or your lead, your managers. Okay, so let's create a template. Now let's name it merge with master. So I'm just giving any name. I give a description. Number of approvals, you can add number of approvals over here. Approval pool member. So there are two options if you have a group created or such. So you can, if you have a IAM username or if you have assume roles created, okay, you have something roles created in IAM, you can give that value over here. So that particular group or a particular members who have that role can approve it. That is one way. The other way is you can just give a fully qualified ARN. That's nothing but it's ARN stands for Amazon resource name. This is how Amazon name their resources. Okay. Now I can just use fully qualified ARN. I'll go in IAM and I will look for some user. So yeah, I can make use of this Rohit KS. This is my another ID. Just assume he is your peer who will be approving your code. I'll copy the ARN. You'll get the ARN right over here. Okay, just copy this, put it right over here. Done. Come down, branch filtration. You can give a branch filtration, like if you want to have your branch as master over here, you can just add that. Okay. Now you can give a repository name. Demo repo. This is the only repository what we have. Okay, I given the branch name. That is the branch, correct? Let me quickly, if it's master or if it is main. Let me quickly check. I think it's master. Okay, it's master. You're good. Okay, now I'll just create. So my template is ready. So what all information I've given? I've given the name, fully qualified ARN. I've given the branch filtration as master. I have given my repository name as demo repo. Just create it. So my template is created. Now coming back over here, let's push something and let's create a pull request again. Okay, let me do a echo again. Subscribe to my channel. Okay, if you guys have not subscribed yet, please do. I'll just give subscribe and just putting anything. Just imagine this is your source code. You're working on an application and this is your source code. So I'm just creating a text file. In this text file, it could be a JSP file, your Java file, your Angular file, it could be anything. The funda remains same. Think what I am doing right now, the same thing you have to do it through IDE or you're doing it directly from a Git console. Okay, so everything remains same. I'll just do a quick commit, subscribe, do a push. Oh, I have made the changes into master branch. Okay, forget it. Let me do a checkout. Develop. Let me do a merge, quick merge over here. Okay, that's okay. So what exactly I did? By mistakenly, I made changes into master. My point was I want to make changes into develop, then create a pull request, then push it into master. Okay, that is what we're gonna do it now. Let me do a git push first, so that whatever changes we did in develop, even my remote develop branch is updated. And let's do the same thing with master also. Let's do a push. So this is the same type of merge what we just did and while creating a pull request. Okay, let's do a switch now. This time I'll not make mistake. Now let's do a echo again. Let's edit the existing file. Let's not create a new one. Let's edit this subscriber file only. Like and share. Okay, now I'll just do a commit. Updated subscriber. Now I'll do a push. Okay, so now we got an additional change in my develop branch, which is not there in my release branch. So if I go in commits, I have a subscriber commit in the master, but if I come back in develop, I have a commit called updated subscriber. Now let's create a pull request quickly. Now there is a change which we can push in master. Okay. Master optional. So you can see what changes we are merging exactly. Now I'll just create a pull request. Now if you see, I have no conflicts, but I have one rules to satisfy. What is the rule? Approval. This needs to be approved. Who would be approving it? The Rohit KS user. Okay. I have my admin rights. If I want, I can override this, but that is not needed. I'll go and approve it. And once the approval is done, we'll do a merge. Okay, let's go ahead and log into that ID. Let me go to IAM. I'm just getting the ARN number, this number. Let me quickly log in. Okay, I was able to log in on Rohit KS IAM user. I'll go in code commit from here. I need to approve that pull request, which is pending because of my approval. I'll go in the repository. If I go in pull request, I can see this change. Okay, now if you see at the top, I have an option to approve. If I just can simply go in, approve the request. So the changes got changed. Now it is approved. Okay. Now if this user, devopsmela user, if you just refresh this page, now if you see the status now, the status is approved. We can go ahead and merge the change this time. Now this time I'll do a squash merge. As I said, what exactly squash merge will do? It will create a new commit for you and it will merge all your previous commits. Okay. So I'll just do a squash merge. I'll give author name as devopsmela, email ID devopsmela@gmail.com. I'll just uncheck this box. I'll do a merge. Okay, the merge is successful. If I go in commits, now squash commit of the following. Okay, we can see a commit. We cannot see the commit which was created. We have done it in develop. The commit was something like updated subscriber. Because of squash, the commit is gone completely and there's a new commit now. This is something created by AWS. So this is what squash commit is all about. We'll see if we can try out the third option, but now for now. Okay, so we have completed all these steps, repository creation, cloning, pull, and we have walked you through all these steps. The only thing is remaining of creation of a custom profile. Okay, so what exactly is the scenario we're gonna see? We have a master branch and a develop branch and other branches. Okay, what we have created. I don't want anyone to come in and push changes into my master branch. Okay, so like for example, I have a developer name. Like if I go into my IAM, I have this developer devopsmela. Just consider this as a developer. I don't want this developer to push changes directly into my master branch. Okay. He can push into the develop, he can push into other branches, but not into the master. In order to push into the master branch, he has to create a pull request. He has to get an approval from his peer. Then only he can push the changes into my master branch. Okay. Understood the scenario, what exactly we're going to do it. So yeah, so if I just for a demo, like this was my repository, I'm just logged in, I'm into a master branch right now. Let me make changes to the existing file. Okay, I have this file DevOps text. Let me edit, subscribe and like. If you guys are not subscribed, please do subscribe to my channel. Thank you. Let me do a quick commit. Updated commit in master. Okay, done. Now let me show you. If I try to push it, I will be able to push my changes into my remote repository. Okay, and currently I'm logged in on my local with this credentials, devopsmela. This is the user who is logged in on my local also. Okay, now I'm able to push my changes. Okay, but the scenario which I want, that the developer uh, should not be able to push directly into the master branch, so he has to follow the different route of creating a pull request. So we have already covered how to create a pull request, how to add approvals and all. Okay, so in order to do that, we need to have a policy attached, okay, to this user. Okay, so let's come back to an IAM. Okay, IAM is access management, which wherein we can attach a policy. So what we are attaching, we are trying to attach a policy which will deny a direct push onto a master branch. Okay, I have some issues with my internet, just give you one quick minute. Okay, so if I just go in, I have 3 users. This is the user devopsmela. So I want to restrict this user by directly pushing changes into my master branch. For doing that, I need to attach a policy which will restrict the user. As if now by default, this user has full access to my code commit. So he can do whatever he wants. But I'll have a additional policy added, inline policy added to him so that he cannot push it. The same thing you can attach to a group also. You can create a group and you can attach this policy, and whoever, like whichever developer you want to restrict, you can just add that developer into that group. Simple. Okay. Now in my case, I'm just restricting this particular user, no one else. Now I'll just create an inline policy. So it's a JSON policy which you can create. There are 2 options. You can go with this visual editor, which will give you an option of choosing one by one things. There's a better option which I like a lot, a JSON. Okay, so don't worry, you don't have to write anything from scratch. You get everything online. You just copy it, customize it the way you want, and you're good to go. Okay, so I've already have this page open wherein I have this policy, my master branch deny policy, right over here. I will share this link in my description. If you guys want it, you can go and use it. I just copy this entire JSON. I'll put it over here. Okay, there are few changes which we have to do. So majorly what we are doing, we're denying. So these are the operations we are denying. Where exactly we're denying? We're denying on prod and the main branch. In our case, it is not prod. In our case, it is master. And if you see, I'm getting an error. So automatically this particular thing is validating whether the syntax and everything is right or not. So I need to remove this. So now things looks good. Let's align this in a better way. Okay, things are looking good. Now the important thing over here, we need to add the ARN, the resource name. Okay, that's how AWS checks the resource, names the resources. So we need to get the ARN. From where will I get my ARN? I'll just open it into a new tab. I'll go to my code commit. This is the repository demo repo. I'll just go to it. I'll go in settings. Do you see the ARN right over here? I'll simply copy this, come back, I'll replace this. Okay, are we good? Just review. So we will just do a quick check if everything is looking good or not. Yeah, looks good. I'll just name it as master deny, something like this. Create policy. Okay, now if you see, I have this policy attached. Now I'll go back again. I'll just edit one of the file again. Let's edit hello text this time. Now I'll just remove this ls. Do like and share. Okay guys, if you like, do like and share. Okay, now I'll just do a quick commit. Okay, master deny rule check, something like this we can just say. I'll do a commit. Now I'll just do a push. Let's wait. Eventually it should fail. Yeah, that is what has happened. Now if you see this remote rejected, so we are not able to push into the master branch. This is one of the policy. There are several other policies which you can apply depending upon your requirement you have. Okay, now if I just go just for a demo, if I just remove this policy from here, done. Now let me try and push it again. It worked. I was able to push. If we want to go and cross check in my commits, you can see the deny commits rule check commit. Okay, how exactly this can be handled? If the user is not able to push directly into the master, he can create a pull request. He can make these changes to a different branch, like a feature branch or a develop branch. Then he can create a pull request from that branch to the master, and he can add a peer review, and based on that, through that he can push the changes into the master. So this is one type of restrictions, so that no one is directly pushing their changes into master branch, because master branch is something very critical wherein we hold a production code. Okay, so that's it from Azure Code Commit. If you like this video, please like, share and comment, and please put it in the comment box. What do you like, what do you dislike, and what all other tools you want me to cover. Okay, thank you and cheers. Bye bye. Hello all and welcome to my channel devopsmela. This is Rohit Singh and welcome to my AWS DevOps series. So in my previous session I have covered what exactly is AWS Code Commit, how do we work through AWS Code Commit, and in this session we'll focus more on AWS Code Build. So let's start and let's understand what exactly a code build is before moving on to a practical wherein we'll be building an application. Okay, so AWS Code Build, it's a fully managed build service in AWS Cloud. It helps us to compile source code. It helps us to run different tests like unit test and things like that. And at the end, it will produce a artifact output. It's nothing but it's a software package which we can go and deploy. It helps us, it completely eliminates building or setting up your own build server. So there's no need of setting up a build server. It has some pre-packaged build environment for more popular programming languages like .NET, Java, Angular, and things like that, Python. So it already had a build environment which you can go and select based on your requirement. With Code Build, we can even create some custom build environments. So if you're not satisfied with the packages or the environments what AWS provide, there is a way out of creating your own build server as well. Okay, so let's understand the build flow. how exactly the code build does the entire thing. So let's understand from the developer perspective. The developer is creating an environment, it's creating a application locally. Post that, once the application is created locally, it pushes the changes in the code repository. In our case, we are referring to AWS Code Commit. So all our code is getting pushed into AWS Code Commit, and we have covered AWS Code Commit in details in my previous session. Okay. Post that the code is built into is fetched or pushed into a code build server. So what all things happens over there? The build server pulls the code from the code commit. It performs the build. It performs a test, and if there's any test coverage, we are performing the test coverage. And if we are performing any code analytics using SonarQube or Veracode, even that step is performed. And later, if everything is successful, later an artifact is created. An artifact is nothing but it's a package, an output file which is deployable. You can deploy it on the end server. The artifact could be a WAR file, it could be a jar file, it could be a zip file based on the application you're using. And post that, the feedback is given to the developer, whether the build was successful or not, whether the build has failed or not. So that's it from the theory part from AWS Code Build. Now in the next, we'll be deploying a live application. So I already have a .NET application. So we'll be using a .NET application over here, .NET Core 3.1, which will be pushing the code into the code commit, and from there we'll be creating a build pipeline. Okay, so let's go ahead and do that. Okay, so let me give you a detour of my application firstly. So it's nothing but it's a simple AWS .NET Core 3.1 application which I have created, and it is simply just displaying welcome to devopsmela. So these are the default controllers, default template of .NET application which I'm using right now. Okay, let me show what exactly the structure is. So there are two. This is my application. Here we go. This is my proj file, and these are two important files. Okay, the build specs file. The build spec file is nothing but my build pipeline will be using this file in order to build. Let me show you what exactly do I have in my build spec file. So these are nothing but the steps which is needed to build this application. Okay, just imagine if I want to build this application locally. So these are the steps which I would be running in to build this application locally. So the same steps are mentioned over here. A build specs file is nothing but it's a specification file for building your application. So it has number of phases. You have pre-build phase, you have build phase, you have post-build phase. Prior to that, if you want to install something, if you want to declare your variables, and at the end, the artifact phase. Okay, wherein I'm getting all the files created inside the build output. Okay? I'm getting all the files if I want to. So I have all the files right over here. So this is a step. Let me walk you through the step. So I have defined the variables over here. This is the name of my application. I'm just calling the runtime version. So this is ASP.NET 3.1, which are we using right over here. In the pre-build stage, I'm just restoring the application using .NET Restore. In the build stage, I'm building the application, and later we are publishing the application. Okay, and even I have one more file to copy. I'm copying the cp proc file in my build output. What exactly that proc file is, let's see that. This is needed for .NET application. So if you see this, I am just executing a command, a DLL command on the URL 5000. So this is important. So all these files, this complete application will be there in my GitHub repository mentioned. You'll find the link in my description. So this is very straightforward, very simple application. It will simply just display welcome to devopsmela, And if you want to test it locally whether it's working or not, we can simply run the test and see it. Okay, let's see. Okay guys, here we go. So this is a simple application, plotted application. Welcome to devopsmela. That's it. These are the tabs what we have. So that's it. This is a very simple application. So this is the same application which we would be building using Code Build, and at the later stage we'll be deploying the same application into Elastic Beanstalk. Okay, so I've already pushed this application in my code repository. So I'm already logged in to my devopsmela AWS management console. If I go back to my code commit, just look for code commit in the search box, you'll find it. If you don't have it over here, you can simply look for it in the code commit section. Okay, you'll find it. Okay, so I already have this repository created. How exactly this repository was created, how did I push and things like that is already covered in details in my previous code commit session. Please do check. Okay, so this is my repository. Okay, so there's a prerequisite. We need to create a S3 bucket. It is required if you want to push your artifact into S3 bucket. Okay, let's do that. We'll push that also. Okay, my bucket name would be something .NET Web App 123. Great. Okay. Region Ohio. That's okay. All the options you can keep it default. Versioning disabled. Encryption disabled. Nothing else. Okay. Go ahead. Let's create a S3 bucket and keep it. Here we go. We have a S3 bucket created. Okay. Let's go back to AWS Code Build now. Okay. So in this source, if you come down, there's a tab called Build. So this is where we have Code Build. So let's go ahead and create a code build project first. The first thing is to create a project. We'll name it as .NET Code Build. Something like this. We'll name it. Okay. Optional description. Enable. If you want to enable batch, you can do it. If you want to enable concurrent build limit, you can do it. Okay, my source is AWS Code Commit. Okay, I'm getting my codes from my AWS Code Commit. We just saw we have our code base in AWS Code Commit. So my repository name is .NET Web App. That's the only branch I have is master. So it will automatically take the latest commit whatever you push. So there are two options for the environments. Okay, either if you want to have a custom image or if you want to use a managed image. So we'll focus on managed image for now. I'll use Amazon Linux 2 to build this application. I'll select runtime as standard. I'll select image, the latest one, 3.0. This is the latest one what we have. Environment type, Redux, that is okay. So this will create a role. So my build, so there's a role which will be created. So let's keep it new service role. So I'll be creating, if you see this with the name of the build pipeline, a role is getting created in IAM. So later if you want, you can go, this particular role will be created in IAM. Okay. Build spec file. So that was the reason why we have pre-created build spec file and kept in a repository root directory. Okay. Now my build spec file name is buildspec.yaml. So I don't need to give any additional name over here. If you're creating a build spec file with some different name like abc.yaml, so you have to give that name over here. If you're giving a different name, okay. Okay, we are not worried about batch configuration for now. Okay, the important part, artifact. Okay, if you want the artifact to be stored somewhere, okay. Now in my case, I want my artifact to be stored in S3. So I'll select my S3, and we already have created a bucket right now. That's .NET Web App 123. The S3 name, even this name should be unique. You cannot use some common name. Okay, it will throw an error and it will not let you create a bucket. Okay, if you want to give any additional name, something like that, you can give it over here. Any path specification, you can give it over here. I don't want to enable semantic versioning also, so let's keep it default. Now packaging. How exactly you want to package? If you want to package it as a zip file, you can do it. Select this option as a zip, and this will be created as a zip file. The complete package will be created as a zip file, and it will be stored into an S3 bucket. So logging. Okay, if you want to start logging, so CloudWatch, there are two options to log your build logs. You can put it into a CloudWatch. You can put it into S3. I don't want CloudWatch for now. Let's do it S3. We already have a bucket. Okay, we can use it for logging as well. Okay, so that's it. These are the options which is needed. Let me see if I missed anything. No, there's nothing I've missed. Let's go ahead and create a build project. Remember the location where I'm creating all this, it's Ohio. Even my bucket was created in Ohio region, and even my build is created into Ohio. Okay, so here we go. This is my build. There are all the options at the top. If you want to start the build, we can simply click on start build, and my build project will start. My build pipeline will start building this particular application. Okay, let's create it. Go ahead and click on start build. This part will take time based on the steps and the task what we have in a build spec file. So I think it's around 2 to 3 minutes it will take to build this complete project. And if you see, my S3 log was enabled, my CloudWatch was disabled, phase details started. The build has started already. We don't have any environment variables over here. You can see my complete build details over here, what exactly we're using and things like that. Reports, we have not mentioned anything about testing and reporting, anything in this particular build spec, so you'll not see anything in reporting part, but you will focus more on the build which is happening right now. Okay, the build was successful. So it didn't took that much of time, it was pretty quick. If you want, you can see the logs over here. Now the build was successful. Okay, if I go back to my build project, see, this is the build which ran. It took around 46 seconds only. Great. So all the phases were completed. There's no failure, so we are pretty good, in good shape. Let's go into the S3 bucket and see if we have the zip file created. So at the top, whatever you see, that's a log file. So remember, we have given this particular S3 bucket name as to upload the logs as well. So if you see, the log was created as a gunzip file. Okay, and in the bottom we have a zip file. This is a zip file which was created. Okay, this is my application zip file, and at the top you're seeing the logs. So that's it from code build. My code build was successful. In the next session, we'll talk about Elastic Beanstalk, and we'll see how exactly Elastic Beanstalk application is created. Okay, thank you. If you like my channel, please do subscribe, and please put down your comments, your thoughts, what you like, what you dislike, what more you want from me. Please put those information in my comment box, or you can even email it to me on devopsmela@gmail.com, or you can even visit my website devopsmela.in. Okay, thank you. That's it. Hello and welcome to my channel DevOps Mela, and welcome to the DevOps series. In this video tutorial, we'll talk about AWS Elastic Beanstalk. So firstly, we'll understand what exactly is the Elastic Beanstalk, a bit description about Elastic Beanstalk. Post that, we'll go ahead and create an Elastic Beanstalk application for deploying a .NET application on top of it. Okay, so let's start. So basically, Elastic Beanstalk is a platform as a service provided by AWS. So what exactly it helps us? It helps us to quickly deploy and manage application in AWS Cloud. So the complete complexity of setting up a scalable infrastructure is taken out completely. So this particular service is for those person who are looking and for building and deploying application with negligible knowledge of other cloud components. If I'm talking about other cloud components, it's EC2 instance, auto scaling, VPC, load balancing, and things like that. So if they don't want to get into those components, if they don't want to learn about those components, they can simply get their application deployed on Elastic Beanstalk. Elastic Beanstalk will take care of auto scaling, load balancing, and things like that. How exactly Elastic Beanstalk does that, we'll see that later. Okay. That is what Elastic Beanstalk does. Okay. It also supports multiple programming languages such as Go, Java, .NET, Node.js, PHP, Python, and Ruby. The four major concepts, the core concept of Elastic Beanstalk is it's a platform as a service. Okay, it helps us for deploying and scaling web application and services. It even helps us for doing auto scaling, load balancing, and continuously it does the health monitoring as well. Okay, it's a platform management and a code deployment tool wherein you can just get your code and deploy it on top of it. So in a simple graph, if you want to understand what exactly how the Elastic Beanstalk works, so this is how it works. You get your application code, you create an application environment in Elastic Beanstalk, you deploy your code. In the backend, Elastic Beanstalk spins up a EC2 instance based on your requirement. It creates, like if there's a requirement of Nginx web server or Tomcat, if you're running a Java on Tomcat, then all the web server and everything gets pre-installed. And using your application code, your application gets deployed on that particular EC2 instance. So all this thing happens automatically in the backend. You don't have to worry about anything. Just get your code and deploy it. And if you want to know about the similar product, what we have it in other cloud environments, cloud providers, Azure, we have Azure Web App, who does a very similar task what Elastic Beanstalk is doing over here. Okay. Again, it's taking out the complete complexity of your other AWS cloud components like EC2, VPC, subnet, things like that. Just get your code and deploy it on Elastic Beanstalk. That is what we will see right now. So if this is a typical graph of Elastic Beanstalk, wherein the users, we are at the user. Okay, Elastic Beanstalk creates a load balancer and it distributes the load. In the auto scaling group, it distributes the load in multiple EC2 instances. And over here, you have all your databases. Okay, that's it from the theory part. Let's jump into the practical part wherein we'll create an Elastic Beanstalk application. And for now, we'll just deploy a sample application on it. And later, using code pipeline, we'll deploy a .NET application, which we have created in my previous sessions of AWS Code Build and Code Commit. Okay, let's go back on AWS console. Okay, this was the code build which we did in the last session. Let's go back and look for Elastic Beanstalk in the top. Elastic Beanstalk. Okay, here we go. Okay, I don't have any Beanstalk running right now, so I'll have to go ahead and create an application. Let's go ahead and create an application, Elastic Beanstalk application. Let's name it as .NET Web App EB. Application tag, I'll just, if you want to give it, you can give a tag name as name, environments, production, dev, whatever you're creating. Platform, it's a .NET Core application, so I'll be deploying it on Linux itself. For now, I'll focus on sample application, but if you have a local file, a zip file, a WAR file, something like that, and if you want to directly upload it into Elastic Beanstalk, you can do it. You can, or if you have your zip file or something like, if your artifact is in S3, if you want to directly upload it over here, even that is possible. But for now, we'll just focus on sample application. I'll go ahead and create this application. So basically, this will go ahead and create an EC2 instance with all the required web server and things like that. And it may take around 2 to 3 minutes, depending how big the EC2 instance is and how big the sample application is. So let's wait for a while. And it's also creating a Amazon S3. bucket. Okay, so all the creation is in progress. Once the Elastic Beanstalk application is created, we'll come back. So let's pause this video and come back once the Elastic Beanstalk application is created. Okay. So guys, the Elastic Beanstalk application was successfully created, and if you can see, the health is also okay, and it's running .NET Core 64-bit Amazon Linux on it. So in the backend, if you want to go and see, let's go and see. There's a EC2 instance created. Here we go. So we have a T2 micro EC2 instance created in the backend, which was created by Elastic Beanstalk. Now, if you want to go and see the default page, what it gives. So this is a default page, a .NET page, which it is reflecting right now. Okay. So that's it from Elastic Beanstalk. In the next session, in the code pipeline session, we'll have a build project created. We'll have a release created, and we'll be releasing a live .NET application on this Elastic Beanstalk. Okay, let's see you in the next session. Thank you. Hello all, and welcome to my channel devopsmela, and welcome to my AWS DevOps series. In this video tutorial, we'll talk about AWS Code Pipeline. So it's a continuation of all my previous video. So in my previous sessions, we talked about AWS Code Build. Prior to that, we talked about AWS Code Commit. And in my last video tutorial, we talked about what is Elastic Beanstalk. So in this, we'll be creating a code pipeline. So let's understand what exactly a code pipeline is. Let's understand the core concept of code pipeline before we jump into the practical part of code pipeline. Okay, so what exactly a code pipeline is? It's a continuous delivery service provided by AWS Cloud. What exactly is continuous delivery? Is nothing but it will help you to automate your build and your release process. Okay, with code pipeline, you can quickly model and configure stages of application release or software release. So there are a few core concepts before we start with code pipeline. Like, let's understand what exactly this continuous delivery is. So in a software development methodology, where the release process is automated. Okay, every software change is automatically built, tested, and deployed to production. Okay, that is what we are talking about, continuous delivery model. But there's a catch. Before the final push to production, a person, could be a person, or an automated test or a business rule decides when the final push should occur. So in many cases, we have a bi-weekly release, we have a monthly release, we have a quarterly release. So at that specific date, a specific time, we do production changes. Okay, so that can also be considered as a continuous delivery model, wherein everything is automated, your build is automated, your test is automated, but before we go and deploy into production, we need approval or as a specific date or time we're deploying the changes. That is what a continuous delivery model is. On the other hand, we have continuous deployment. So again, it's a software development method where the release process is automated, same like delivery. Every software change is automatically built, tested, and it is deployed till production. That is the only difference between delivery and deployment. In delivery, you're waiting for an approval to deploy it in production. In deployment, if you're following a deployment model, no manual approval or intervention is required in deployment model. It will be deployed till production. The only thing can stop if there is a test failure, if there's a build failure, and if everything is smooth, things will get deployed in production. Okay, and the feedback will be given. Continuous integration, we already talked about continuous integration during a continuous code build phase. Let's talk about again. So continuous integration is focused on building and testing your code. Okay, and at the end it will create an output, an artifact which can be deployed on your end servers. Okay, that's it from the core concept and from the code pipeline. let's see a graph, a workflow, how exactly the AWS code pipeline works. So being a developer, we push our changes into a source code repository. So in this case, we're using Code Commit. Then the build starts. Again, we are using Code Build over here, and things gets deployed into the staging environment. Okay. Post the deployment into production, we have a manual intervention in between, wherein if you want manually, someone will come and approve it, and then the changes will be deployed into production. That is what is followed into mainly into code pipeline. So next, we already have a .NET application which we would be deploying it on Elastic Beanstalk. So in my previous session, we have created this Elastic Beanstalk services. So let's go back to code pipeline. Okay, let's look for code pipeline, and over here we have a code pipeline. So there are multiple phases in code pipeline. Like we have to define the source, we have to define the build, then we have to create the build, deploy. Okay, so these are the stages in code pipeline. Let's go ahead and create a pipeline first. Let's name it as .NET Web App CP code pipeline. Okay, a service role would be created, which is very much needed for a code pipeline to connect to all the other services and to gain access. So the service role is automatically created. If you go and check in your IAM, post this creation, this role would have been created till now. Okay, not wrong, once the code pipeline is created. Okay, advanced settings. So if you want to store your artifact, it will be stored into a S3 location, S3 bucket. Okay, it uses encryption key, so we keep all this thing default. I'm not making any changes to it. Go next, source. So my source is AWS Code Commit. So my source code is kept over there. So I'm using the AWS source commit. I'll just give a repository name as this is the repository which I'm using right now. I'll give my branch name as master. That's the branch I have. Change detection option. So there are two ways it will detect the change, either through CloudWatch events or through code pipeline. So if I select code pipeline, so periodically my code pipeline will go and check if there is a change in my repository, then or if there's a change in my build, things like that, and it will trigger this complete process. Okay. Or so let's stick with the CloudWatch event. I'm not making changes to the output format, so let's keep it default. Build. I already have a build, that is code build. In my previous session we have created a build project that was .NET Code Build. So I'll be using that. Build type. I'll stick with single build for now. Go next. Deploy. I'll be deploying it on Elastic Beanstalk. So we have created this Elastic Beanstalk as well. So that was the only reason I have created each and everything prior. Okay. And my Elastic Beanstalk is there in my Ohio region. So that is the reason I said previously that focus on which region you're creating the resources. Okay. Application name. This is the Elastic Beanstalk what we have. The environment is .NET App EB-environment. That is the environment which we have created. Next. So these are the pipeline settings. What we have. The source stage, what we have, the build stage, what we have, the deploy stage. These are the 4 stages what we have in. So let's go ahead and create a pipeline. As soon as we create a pipeline, my code pipeline will trigger initially. So it will start the build and deploy process automatically. So let's see. So if you see at the extreme right, the source stage has already triggered. So this may take around 3 to 4 minutes. So let's wait and let's come back once the complete deployment stage is done. So if you see the source stage is completed, now the build stage has already triggered. Okay, so let's wait and let's come back once things are done. Okay guys, so my code pipeline was successful. So it approximately took 5 minutes for the complete process. So the source was completed, it was successful, the build was successful, and even the deployment stage was successful. Let's go and see at the Elastic Beanstalk if our application was deployed successfully or not. Okay, we are inside this. Let's go inside the environment. Okay, and let's see. Here we go, guys. So welcome to devopsmela. So our application was successfully deployed using a code pipeline on Elastic Beanstalk. So now let's make some changes and let's test the continuous deployment model with code pipeline. So I'll use the Visual Studio tool. I'll make changes to the index.html file itself. devopsmela add Elastic Beanstalk. Okay. Let's save this. If you want to run this and test it locally, you can do it. Let's push the change. Updated index file. So my expectation is once we push the changes into my code commit repository, my code pipeline should automatically trigger. Let's see if it happens or not. Still pushing the change. Okay, it was successfully pushed. Let's go back. Let's refresh this page. Let's see if the stages have started or not. See, while we were talking, this was already done. The source part was already done. The build has started again. So the build is running right now. So let's wait and let's see if the whatever changes we made locally, if that changes are getting reflected over here or not. So let's wait and let's come back in a couple of minutes. Okay. Okay, all, even this was successful. So let's go and see and just refresh this page and see if the changes are reflecting or not. Okay, welcome to devopsmela Elastic Beanstalk. So even this change, the continuous deployment model is working perfectly. So that's it from this complete series. Please put down your thoughts, your comments in the comment box. And if you like my channel, please do subscribe. Okay, I spent a lot of time creating this video. So please like, share, and if you have any thoughts and if you want me to cover any other topic apart from AWS or Azure, please do let me know. Please put down in the comment box or email me. Send an email on devopsmela@gmail.com or visit my website devopsmela.in and put down your feedbacks over there. Guys, I'm seeing this feedback comments, each and every comments. Okay, please put down your comment and please do subscribe to my channel. That's it. Thank you from my side and have a great day. Goodbye.